One. So we are jumping ahead to this lesson on logarithms. Logarithms start in section 9.5 and then continue in section 9.7. We're going to combine it all into one lesson. So there is a definition here of logarithm, and you're welcome to pause the video and write that down if you want to. This is a hard one for me to describe in words. I tried to reword, the textbook definition, because sometimes I think those are complicated, but even that I don't feel is super useful. So let me just show you what a logarithm does. A logarithm is another way of rewriting an exponent or an exponential function. So, for example, we know that 2 to the third power is equal to 8, okay? So what a logarithm does is it's written this way: log base 2 of 8. And that 2, that's like a subscript 2, that's a little 2 down kind of set below the line. And what this question is asking is what power turns a 2 into an 8? And then we would say the answer is this exponent here. The answer is 3. This is how we would write this in logarithmic form. Okay? Log base 2 of 8 equals 3. And the reason this is really helpful to us is it lets us bring this exponent down into like kind of the main line of the problem. So we can now do some math with these exponents. Okay? So anytime I'm taking a log of a number, really what I'm looking for is an exponent. A log at its core is an exponent. Okay, so let's just generalize that a little bit. When we write things as exponents, we write them something along the lines of, b to the power of x equals something. I don't know, a, let's say. B to the power of x equals a. To write that in log form, you're going to use the abbreviation log, and you'll hear me refer to these as logs most often. Base b of this number here, and I don't really know what this number would be called, okay? So we've got the base here, and we've got the exponent here, and I'm not sure if there's a word for what the answer is, but that's the number that's going to go next. That's this number that goes here, and then the answer to a log is the exponent, okay? So when we're in this form, this is our base, and this over here is our exponent. And you're going to hear me refer to this as like the circle method, okay? The circle method, all I'm saying is that's the order that you kind of go in when you're converting from one to the other. So if I'm in log form like this, and I want to rewrite it in exponential form, I start down here with the base, okay? And I say b to the power of x equals a. That's the order that those pieces go in. B to the power of x equals a. Or if I was in this form and I wanted to turn it back into a log, I would start here with the base. B, log base b of a is equal to x. So either way, it's got that same kind of motion to it. Okay. One more quick definition to throw at you. A common log is a log base 10. Okay, so where this number down here is a 10. You can do a log in any base you want. Up here I did a base 2. You could do a base 5. You could do a base of pi if you really wanted to. Common logs tend to come up more often than the others. And you're going to learn a little bit about why that is, later in the chapter. But just to give you some context here, and I don't know that you should take the time to write this down, but you remember how, like, if I write x plus 10 like that, we assume that this is a 1, right? If we don't write it, we assume that there's a 1 there. Or similarly, if I write the square root of something and I don't put a number up here, we assume that it's like a 2, like a square root. So with logs, if there's not a base written, we assume that it's a 10, okay? So if I just write log of x like that and I don't put a base down there, really what that means is my base is 10, okay? So the common log is the one that you kind of assume by default. Now, the common log is important for a couple of reasons mathematically, but why it's important to you is this is the one that is found on your calculator, okay? If you look at the left-hand side of your calculator, you should see a log button, okay? And that log button is doing a common log. That's the one that your calculator is designed to do for you. If it's in another base, your calculator really doesn't do it for you. And I say that knowing full well that some of the newer, fancier calculators will do other bases for you, but I'm going to work with it under the assumption that your calculator does not. And I will show you ways that you can get around that, but you should know that the common log button is there on your calculator. Okay, so we're just going to try a couple of these, and we're just going to try rewriting them in the other form. So basically what we were talking about, up here with these two things. Can we go back and forth between the two? So when I have 3 to the 4th equals 81, I would rewrite that as log base 3 of 81 equals 4. Log base 3 of 81 equals 4. Make sure you're trying to be pretty neat when you do this. You do want to make sure your base is set down below the log a little bit. Okay. For this next one, it would be log base 3 of 27 is equal to x. And remember, what I'm really asking myself there, if I was trying to figure out what x was, is 3 to what power makes 27? Okay, you actually know the answer to that one already. So you could solve that if you wanted to, but all we're doing is rewriting it as a log. Okay, this next one has no numerical context, so we have to just try to figure out what goes where. It would be log base m of k equals p. M of k equals p. Okay, that's really all there is to that part of it. We're going to do some math with it in a minute, but all right, now let's see if we can go the other way. Let's see if we can take logs and turn them back into exponents, and my motion is going to be the same. So 4 to the 3rd power equals 64. That's what this thing is really saying. 4 to the 3rd equals 64. Okay? So with this next one, I would say 2 to the power of 12 equals x. Now, on that one, I think that I could go ahead and solve for x if I wanted to, right? I could just do 2 to the 12th power, and then I'd have my answer. On this next one, log of 100 equals x. Remember that if there's no base written there, we assume that there's a 10, okay? So this is really saying 10 to the power of what makes 100? And I'm hoping that you could solve that one on your own, okay? That would be x equals 2 if it did ask us to solve. Okay, so that last example made me think of one quick thing that I wanted to kind of review with you. If I ask you for the common log of 100, we would say that that's 2. You could try that on your calculator if you wanted to. Again, because of what we just talked about here, 10 to what power makes 100? So if I wanted log of 1,000, I'm really asking myself 10 to what power makes 1,000? Well, that would be a power of 3 because there's 3 zeros there. Okay? If I really wanted to, I could do log of, I don't know, 1 trillion. So let's see, there's a million, there's a trillion. And we're saying 10 to what power makes this 1 trillion? Well, that would be a power of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So when you're working with positive powers, it's a matter of counting the zeros here. Let me just throw this one in here. If I asked you for just log of 10, that would be 1, right? Because 10 to the 1st power makes 10. So then what would be the log of 0.1? Okay? Well, let's think about this. If I go down in increments of 10, my next one here would be log of 1, and that would actually be equal to 0 because 10 to the 0 power makes 1. So log of 0.1 would be equal to negative 1, okay? Because 10 to the negative 1st power is equal to 1 over 1,000, or sorry, 1 over 10. Let me rewrite that down here. 10 to the negative 1 power would be 1/10, which is 0.1, okay? So if I ask you for log of 0.0001, we have to think about how many decimal places that is. This gets a little confusing. This would be -4. Okay? Just like this was -1 because it was one place after the decimal, this one would be -4 because it's 4 places after the decimal. When you're talking about after the decimal point, we're no longer just counting zeros like we were back here. You're counting how many total decimal places there are after the decimal point. Okay? I suppose if you put a 0 in front here, you could say that you were counting the zeros, but really it's more of a matter of what's behind that decimal point. So if you get stuck on one of these, okay, because there is going to be a no calculator part of this chapter, this is exactly what I would recommend you do, is start writing out a few of these powers of 10, and then I think you'll start to see the pattern, and then you could come up with it off the top of your head. Okay, let's see where we're at. Time-wise, I can probably get one more example in. Let's flip to the back here. And I think actually I'm going to skip example 3 for now and come back to that in another video. I want to just hit example 4 here. Actually that first example we already did. We did that on the previous page. We had log of 100 equals x. We said x equals 2. Okay, so let's look at this next one. Log of x equals -3. Well, this is really like a base 10, right? So if I spin this thing around to exponential form, it would look like this. 10 to the -3rd power equals x. And then it's just a matter of figuring out what 10 to the -3rd would be. Well, it's going to be 3 places after the decimal. So it would be 0.001. Okay, 3 places after the decimal. Also, 10 to the 3rd is equal to 1,000. So that negative would make it 1 over 1,000, which is the same thing as 0.001. So if you're more comfortable with it in fraction form, that's fine too. Okay, so this next one, I have x to the power of 2 equals 49. So I'm going to have to square root that, and I end up with x equals 7. Now, normally at this point in the game, I'd be harping on you guys to remember to do a plus or minus when you take that square root. With logs, you're never going to have a negative base, so we are safe to assume it's just 7. Okay, and then this last one, I get 3 to the 5th equals x. And so this one, the x is over here, and I just have to figure out what is 3 to the 5th power. I think that's 243. So x would be 243. And so if I had had log base 3 of 243, the answer would be 5. Okay, so that's it for right now. This section up here, this example 3, there will be a second video covering these because this is exactly what's on your no calculator quiz, which will come up the week after spring break. So I don't want you to stress about that right now because we are gearing up for break, but you are going to watch that video and do these examples, and then I want you to refer back to these examples when we get ready for the no calc quiz. So you may even want to make a note right on your notes that this right here is exactly what you need to be able to do when it comes to that first quiz we're going to take. Okay, that's it for this video. Like I said, there will be a second follow-up video. You do need to watch both of them, and then you can get going on the homework assignment.